solid structure. Okay, when you will heat that, it will melt down on the pan, on the frying pan. When you will heat that frying pan, it will melt down, and when you will continue your heating, it will start solidifying rather than vaporizing. Getting it? Generally phase is solid, solid to liquid, liquid to vapor, and then super vapor or superheated vapor, that way. But what is happening with the egg omelette? First of all, semi solid or semi liquid, then converting into liquid, and then converting into solid. Okay, so this second example was for the thermosetting, and first one ice cube was for the thermoplast, right? So in case of thermoplast, you will heat it, it will liquidify. You will cool it, it will solidify. Okay, in case of thermosetting plastic, thermosetting, so it will settle once you will provide the, or once you will supply the heat. Okay, and in case of microstructure, with respect to thermosetting plastic, it was having a complex structure, and in case of thermoplast, a parallel simple linking structure was there. Okay, so that we have seen. Properties also we have gone through, basic properties. We know that plastic very easy to melt, so it can occupy any type of complex shape. Flowability is good. Okay, melting point temperature is less, so can be used for a different type of application. Good mechanical properties. Density is less, that is one of the thing. Good damping capacity. It can be used as electrical insulator or thermal insulator. Okay, so that was the some basic properties we have seen. Now today we will see some of the applications of the plastic with respect to the its structures or its chemical structure, right? And later on we will see the applications based on the areas, like in agricultural, in the industrial field, in the day-to-day applications. Okay, first of all we'll see some of the applications based on this chemical structure. Now, here you need to understand one thing, that some names are quite different. I will not say the difficult, but these are some different names. Different in the sense, these are chemical names. I mean, you may have gone through it in your 12th also. So we need not to go to the its basic, means chemical structure, chemical bonding, atomic structure, then that C, C, H, and O chains. Okay, we will not go to that monomer level or the macro level. We'll see only the name and its applications. Okay, so the chemical part is not there with us. We are having processing, testing, and application. Okay, that is the agenda. So definition we have seen, classification we have seen, properties also we have gone through. Now we'll see the application. Okay, so one by one we'll see. So this is the generalized view I have given. Use of plastic for different types of application. Okay, so there are see, you cannot limit the applications of plastic. Means we are using only here, we are using only there. Okay, it is having wide variety of applications. Just change the chemical structure, add some additives. Okay, combine it with the non-metallic materials, and you will get a plastic composites. You can use it to different applications. Okay, so based on its structure, based on its composite materials, maybe a fiber, maybe a like plate type composites. Okay, so based on that, you can have different types of applications. So this is generalized view I have given. Bath and sink units, ball floors, corrugated sheets, laminates, electrical conduits, electrical insulators. Okay, waterproofing, floor titles. Okay, see, you may have seen the floors in your home also, that are mostly made from the ceramics. Okay, tiles. Okay, floor tiles. But nowadays, because of the indisposable nature of the plastic, floors are made from the plastic material. Okay, that pavement blocks. Have you seen the pavement blocks? See, the generally pavement blocks are made from cement concrete. Getting it? So that nowadays culture is that instead of cement and concrete, pavement blocks are made from the plastic. Pavement blocks are made from the plastic. Okay, so That is the new thing they are using. Jointless flooring, lighting fixtures. Okay, if you see the material of the fan and your tube lights base, okay, tube light sheets are there, okay, that are made from the plastic. Paints, plastic plant. You know the concept of plastic paint. Pipes to carry the cold water, okay, or PVC pipes. Roof lights, safety glasses, wall tiles, water resistance adhesives. Okay, so this is generalized view. Okay, this need not to keep it in mind. One by one, we'll see, okay, the different applications of the plastic. Now, this see the for every example I have given you the picture so that you can understand it easily. Now, let's see the first one. Now, you may have came across this word polyester, because this textile material is made from this polyester. Okay, so mostly this polyester that is used for this textile and to make the fiber in the sense, again, that fibers are made together to make a complete sheet of textile. Okay, so if you see just one material I have given here, this tie. Okay, even you will find so many types of different types of cloths made from the polyester. Okay, if you see, there are different types of cloths. You will find some made from the cotton, pure cotton. The pure cotton textile materials are different, and made from the polyesters are different. Getting it? So pricing is different, properties are different, quality is different. uh, that what we can say, surface finish or that glow is different, right? So generally, mostly the ties are made from the textile. Sorry, this polyester material. So that I have given you this. But shirts, pants, everything, wherever you will find, this is made from the polyester. So this is one of the example of the plastics that is a polyester, and the basic application is in a textiles or to make the fibers. Okay, so it is called as a polyester plastic. Polyester plastic. Okay. So see, whenever you will visit any textile shop, that particular owner or that who is going to that particular person who is there in a shop, he will immediately ask you what type of cloth you want. Will it be a cotton shirt or a polyester shirt, right? A cotton sari or polyester sari. Okay, that way, because costing is different and quality is also different, right? So if I want to say the specify, like if you purchase a cotton material, and if you purchase polyester material, so that ironing is not required for polyester cloth, but ironing is required for the cotton cloth. Okay, so so many differences that type. So the first is a polyester. Second, this you may have seen everywhere, a PET bottles. The name itself is a PET bottles. Okay, generally we are calling it as a plastic bottles, but the authentic name is a PET bottles, right? So this PET stands for polyethylene tetraphthalate. Okay, polyethylene tetraphthalate, that is called as a PET bottles. So our whatever the drinking water, this cold drinks, these shampoo bottles, and mostly uh, food coverings, everything you will find this in this type of PET bottles. Okay, so this is also a major application, that is called as a polyethylene tetraphthalate. This is the one type of plastic mostly used for carbonated drinks, mostly used for carbonated drinks. Okay, now you may study, you will study in a metallurgy also. See, in case of carbonated drinks like your thumbs up, Coca-Cola, Pepsi. Okay, there are two options: a bottle made from the glass also, not for carbonated water, sorry, carbonated drinks, for everyone, everything. There are two options: a bottle made from the glass and bottle made from the PET or the plastic. Okay, there are some advantages with respect to first, and there are some disadvantages also. Okay, if you see, in the old days, that thumbs up, cold drinks, and Pepsi, today also you will get that it is usually there in a your glass bottles, but afterward they have removed that glass bottle, and now it is completely in a these PET bottles. Okay, so the thing is that weight of the particular bottle and the nature of the glass, a brittle nature of the glass. Okay, if you throw that this plus particular plastic bottle of cold drinks, if you throw from some distance, it will not break. But if you throw that glass bottle, it will break down easily. Okay, so that was the advantage of plastic. But disadvantage is that glass bottle is a reusable type. Getting it? Whatever the glass bottles previously used, see, if you go to the shop now also, and if you purchase a cold drink, suppose a Pepsi or Coca Cola, and it will be filled in a plastic bottle, you can purchase it, you can take it to the home. But in old days, this plastic and sorry, this Pepsi and Coca Cola used to be there in a glass bottles. That time they were not allowing you to carry that bottle to your home. Have you experienced that? Because that glass bottles are recyclable. Okay, and they were doing that, the recycling of the bottle, but that is not happening with the plastic. But so the cost also, cost of the glass bottle is more, cost of the PET bottle is less. Okay, so the major application is like this PET bottles, polyethylene tetraphthalate. Okay, so first example is polyester for a textile, and second is polyethylene tetraphthalate, that is a PET bottles. The name itself is a PET bottles. Second, a very famous example, polyethylene. We generally have only two words, a carry bag or polythene bag. Okay, generally we call it as a polythene or carry bag. Okay, so this type of carry bags that we are mostly using for each and every type of material carrying purpose. Okay, nowadays there is a ban on this particular carry bags or polyethylene bags, or this is called as a polyethylene plastic. Okay, so this is mostly used for manufacturing or production of carry bags, which is called as a polyethylene polyethylene plastic. Okay, now it is used for the carry bags and also for plastic bottle also. Okay, now advantage is that very less costly. Okay, and easy to carry and durable also. But this the most uh, important problem with this polyethylene or carry bag is that non-degradable nature. Non-degradable nature. Okay, if you throw this carry bag or polyethylene bag anywhere, and after 10 years also, if you will dig that particular space, or if you find there, that carry bag will be, you will find that carry bag there only. Okay, because non-degradable nature. Okay, so there is a ban nowadays here. But so this is the major application, polyethylene bags. Second is HDP. Okay, you have seen also this HDP mostly in a piping industry. Okay, this HDP stands for high density polyethylene. Now, similar structure is similar. This is also polyethylene, first one, and second one is also polyethylene. But the first one is a low density polyethylene because of the nature of the application. It is just only used for the carrying simple materials, one time use. His second, here you will find this like and engine oil bottles, like Castrol, Bosch oil, okay, that type. Even your liquid fertilizers that are used in agriculture applications that are coming in this particular type of bottles, isn't it? So if you see this particular structure of these two materials, the first is having less density plastic, and second it is having high density plastic. Plastic in the sense polyethylene, so that the strength of this particular bottle is more than strength of this carry bag, and so the applications. Okay, for the costlier applications, they are using this HDP, high density polyethylene. Same nature, same structure, only the density is more. So it is used for some different application. Okay, so high density polyethylene. So your phenyl. Okay, then if some acids are there, like toilet cleaning acid, a floor cleaning acid, right? Detergent bottles. These are coming in this particular HDPE type of plastic. This is called as a high density polyethylene. High density polyethylene. So first was polyester, then PET bottles, then polyethylene, then high density polyethylene. Okay, there is one more word here, low density polyethylene also. It is called as a LDPE. Okay, I have not shown here, but there is a one more application, LDPE. What is going to happen? See, this in case of this polyethylene, density is very very less. In case of high density polyethylene, density is very high. But in between that, there is one more like type of plastic, that is LDP, low density, where density is more than polyethylene but less than HDP. Okay, so that is also used for the manufacturing of the plastic bottles. Next is very known applications. Your agricultural pipes, or not agricultural, you will find this type of place anywhere in your home also. Okay, for carrying the water, or in your industry it may be used for the carrying the oil, chemicals, anything. Okay, so it, the name itself is a PVC pipe. Name itself is a PVC pipe. Okay, and we are known about this polyvinyl chloride. It is a plastic. Okay, so it is known as a PVC pipe. So your plumbing pipes and even windows. Okay, if you see, I'm not telling about the that uh, steel structure of the window. Okay, that movable window is there. Okay, that is made from the PVC. Okay, PVC windows are also coming, so that making the manufacturing of the windows, then production of this particular pipes, this polyvinyl chloride is used. That is also one type of plastic. It is a polyvinyl chloride. And there is one more one concept that's called as a PVDC, polyvinylidene chloride. Polyvinylidene chloride. Okay. Now, whenever you will travel through via train, and if you purchase food packets, if you purchase a food packets, you will find that food packets are closed, or that food material is packed in a silver like material. That is not made from a cloth, that is not made from a cotton. You will find that silver like whitish color, like a paper type material. It is neither a paper nor a cloth. It is a plastic. It is a plastic, and that is called as a polyvinylidene chloride, PVDC. A similar kind of structure as like PVC, but with less density. And also, obviously, applications are different. Polyvinylidene chloride. Okay, so the major application will be food packaging. Major application will be food packaging. So you will find silver like that particular material which is closed on the food. Okay, mostly what is happening, that food packets are there where the base material is different. It may be a different plastic, but that layer, outside layer, is made from this PVDC plastic material. Okay, it will not react with this particular food. Okay, that is a major importance. Even the car bumpers are also made from this material. Okay, so you will ask that how the particular strength will be maintained. Okay, so obviously the size of that particular material, the combination will be quite different, but the basic material will be this PVDC. Okay, even your drinking straws. Okay, while drinking a juice, or while having that cold drinks, whatever the straws you are using, that are made from this polyvinyl chloride. Are you getting the application? See, in that straw, see, this PVC material you cannot use for the straw purpose, because that straw we are keeping it in our mouth, uh, in between the lips. Okay, so it is directly coming in contact with your body, so that it is different from PVC. PVC is just for carrying the liquid materials, but this is directly coming in contact with the human body, so that this chemical structure is different. Okay, so packaging of the food, drinking straws, car bumpers, and bottle caps also. So sometimes bottle caps also made from this particular polyvinyl chloride material. Okay. So what we have seen up to this: polyester for textile, PET bottles, polyethylene, carry bags, HDPE, high density plastic, PVC for carrying purpose, PVC pipes, and then PVDC for mostly food packaging, plastic bottles, sorry, bottle caps and straws, car bumpers. Next is a polyamides. Polyamides. Okay, this type of nets you have seen, sometimes you will find this with fruit sellers also. Fruit sellers, maybe while selling the lemons. Okay, so this is like a nylon. This is like a nylon. Okay, so this is made up from the polyamides. Is one type of plastic, and mostly fibers are manufactured out of these polyamides. Okay, one of the major application of polyamide is your fibers of that toothbrush. Getting it? The material of the base material of the toothbrush is different, and whatever the fibers are there on your toothbrush, small straws or fibers that are made from these polyamides. Okay, that are made from these polyamides. So this is used in toothbrush bristles, low strength machine parts, and nylon. Okay, nylon strings you have seen, right? So this is called as polyamides. Now the next one is a very very important and highly used plastic, and it is popularly known as ABS. It is popularly known as ABS plastic. Okay, so many applications in your electronics, mobiles, television set, computers, toys, equipments, keyboards, printers, drainage pipes, monitors, everywhere. This ABS plastic you will find. Okay, it is known as acrylonitrile butadiene styrene. Okay, again, don't confuse with the name. It is a chemical nomenclature. Okay, it is coming from everything is coming from this chemical nomenclature. This polyvinyl chloride, polyvinyl chloride. Okay, then polyethylene tetraphthalate, polyamides, and this acrylonitrile butadiene styrene, popularly known as ABS plastic. Okay, major applications. Every application with respect to electronics, starting from your mobile, electronics toys, electronics gadgets, laptops, PCs, everywhere. Okay, so wherever this electronic applications will come, this ABS plastic is used. Okay, ABS plastic, acrylonitrile butadiene styrene. Next one is polycarbonate. Now this also you know, polycarbonate sheets. Okay, polycarbonate material, right? So this polycarbonate, right? This okay. See, this ABS is used for manufacturing inside part and body of the laptop, though it is a electronic material. Okay, so this is body and this is made from the particular ABS plastic. Getting it? But lenses, windows, this disc, this particular front screen, that is made from the polycarbonate, right? Again, this covering of this heavy suitcase, that is made from the polycarbonate. Okay, so mostly the shining of the polycarbonate plastic is better than the other type of plastic, right? So your eyeglasses, sunglasses or eyeglasses, that are also made from the polycarbonate metal. This disc is also made from the polycarbonate material, right? So these are the applications of polycarbonate. And here is the combined this ABS and this polycarbonate, that is called as a PCABS. So this is a mixture. This is not a separate category. This is a mixture of PC and ABS, mostly used in the interior of the vehicles. Mostly used in the interior of the vehicles. Okay. Now, why it is used as C? Uh, Plain ABS a simple ABS material, if I will use, it will not have a good quality surface finish. But the properties required for electronic applications are with this ABS plastic. But surface finish and glossy surface finish is good with this polycarbonate. So by this combining ABS and PC, you are getting both the properties here. What you required in the vehicle interior, good surface finish, uh, good look, as well as so many electronics devices are fitted inside this particular metal, this plastic material. So that it is combination of PC and ABS, polycarbonate and this acrylonitrile butadiene styrene. Okay, so this interior is mostly made from the combination of polycarbonate material and the this ABS plastic material. This foams, okay, this type of foams, you may have never thought that this is also plastic. Okay, polyurethane, polyurethane. Okay, PU foam. It is popularly known as PU foam. Now, I need not to tell about the applications of these foams. Cushions, right? Basic application is a cushion. Okay, so each and every type of cushion, these foams are used. Again, that cleaning purpose, and that is the secondary application. But basic application is a cushion. So that is made from the polyurethane plastic. That is made from the polyurethane plastic. Okay, and next one is a melamine formaldehyde. It is a separate category of plastic. Melamine formaldehyde. Now, if you see this picture, you will say that this type of cups or saucer, it is a ceramic material. It is a ceramic material, bowls or cups. Okay, but see, you can check at your home also. When you will find the or when you will break this particular material, this bowl, you will find there is a one layer about over this particular surface. You can remove that layer easily. You will find that inside that layer there is a different material. So whatever you are observing over this surface and this inside surface, that is the plastic. And inside that surface there is a ceramic material. Obviously this product is a ceramic product, but this coating is done with the plastic. Because see, ceramic material will not give you a quality surface finish or this type of texture or this type of design, okay, which is required mostly in a household applications. Okay, so see, you can see it at your home also. You just break it, that particular bowl, and you will find there is a different layer on the surface, and there is a different material inside the surface. Okay, that surface layer is made from this melamine formaldehyde. There is a special purpose plastic used for mostly coating purpose because of the good surface finish. Okay, so the applications will be in the molding box also, in the balls also, a decorated top also, like it is used as a paper laminate. Okay, sometimes this type of material is used on your tables also, just as an as to have a good surface finish, a good texture. Okay, it will be there. See, on the table you will find this particular surface made from the this particular plastic, and inside that you will find wood. Okay, table will be made from the wood, but surface will be from this particular plastic. Okay, melamine formaldehyde. And last one is a epoxy, popularly known as epoxy, but the chemical name is polyepoxide. Okay, now you have seen this, right? This is mostly used for making the composite materials. Okay, this nature of this particular material is that it will come in this type of liquid, semi-liquid or semi-solid structure, and when you will mix it with some another metal, it will solidify. So, and this solid nature is very very strong. Okay, so this is called as a epoxy, which is used for getting any type of composites. See, in composite, what you want, there should be a strong bonding between the different materials that you have used for making the composites. Composite means what? You are taking material A, you are taking material B, and you are combining it, and you are generating new. composite as a C. So there you need to have a quality bonding between A and B, and that bonding is ensured by this epoxy. That bonding is ensured by this epoxy. Okay, so this is used as an adhesive. This is used as an adhesive for manufacturing the composite material. For manufacturing of the composite material. Okay, so these are the applications based on the chemical nature. So this epoxy, then these bowls or the table plates, table coverings, then foams in terms of polyurethane, vehicle interiors by using the combination of polycarbonate and ABS plastic, polycarbonates, ABS plastic for electronics applications, toys, polyamides. Okay, example is nylon, then polyvinyl chloride specifically for food packaging, PVC pipe, polyvinyl chloride, HDPE, high density polyethylene, okay, plastic bottles, simple polyethylene, carry bags, PET bottles, polyethylene tetraphthalate, polyethylene tetraphthalate, okay, PET. The name is like that only, PET bottles. And the last one is polyester. Okay, application is the textile or the fibers. Okay, so these are the applications of the different applications of the plastic. Okay, now see, if you see each and every area we have covered: clothing, bottles, carry bags, then plastic bottles for food packaging, oil packaging, carrying pipes, food packaging material like nylons, electronic equipments, automobiles, then electronic equipments, carry bags, discs. Okay, so you will find every household applications, foams, epoxy. So every area you will find there is application of this particular plastic. Okay, so these are the applications, different applications of the plastic. Right. So here are some overview is given which areas are there for the use of the particular plastic. Okay, so we have covered this definition, classification done, properties of plastic, applications, and now testing methods of plastic. Let's go for the testing methods of plastic. Okay, see, once again I am repeating, you need not to go to the depth of the chemical structure and chemical analysis of the particular plastic. Okay, we are mostly going to deal with the manufacturing, processing, and testing of the, even manufacturing also we are not looking after, processing and testing of the plastic with respect to applications required. Okay, so now the testing part. Okay, now the testing part. So these are some basic tests. You may have seen that test in your SOM also, in your EMD2 also, machine design also. Similar kind of structures test which you may have seen for metallic materials. Same kind of tests are used for the plastic also. Okay, so these four basic tests we are going to study. Now see, already we know that plastic is used for so many applications, and depending on the application a different test is required. If suppose I am going to use that plastic material in machine parts, in some heavy duty parts, that time for me tensile test is important. If suppose I am going to use that plastic for food packaging purpose, okay, as a PET bottle for carrying that particular cold drink or water, that time need is not the strength, need is chemical behavior of the plastic. If suppose I am going to use the plastic material for some heating applications where the thermal heat exposure is more, that time heat test is important. Okay, like a creep test, that is important for me. Okay, so depending on the application tests are different, so many tests are there, but basically we are going to see four mechanical tests which are generally used, and then and another test we are not going to see because that are not the our scope. but there are so many tests. Okay, so let's see this one by one. The first one, the most important, a tensile test. Okay, now let's make it interactive. Tensile test, simple to understand, easy. You already seen that, you already performed that. Okay, now tensile test. Okay, so tensile test is basically used for understand the nature of the particular material under tensile loading. Under the tensile loading. Okay, so see, if you see this particular picture, this is the specific type of plastic with specific dimension. Okay, dimensions are already fixed, and from top and bottom it is fixed in between two fixtures, right? This bottom fixture is a fixed and this top fixture is a movable type. Okay, so this you can consider as a base plate. Now what is going to happen, this is a movable type and it will stretch this particular plastic to the upside, and at some instant this plastic will break down. Okay, and through that we'll get this stress strain curve. Through that we'll get this stress strain curve for the tensile test. Okay, which is the output of the tensile test. Okay, now, okay, now first answer I want from you is that have you performed the tensile test maybe in your second year, or are you heard about the tensile test? Have you heard about the tensile test? Okay, okay, have you performed it? I think it is in metallurgy. Okay, maybe in your diploma also some of your friends have conducted in diploma also, and in second also, second year also, or even in SOM also you have gone through this tensile test. Okay, so it is a to check the tensile strength and ultimate stress and elongation of this right in diploma. Okay, if suppose I think the metallurgy is in this semester also, semester only. So in metallurgy that tensile test is there. So we'll revise some of the concept. Okay, so through this tensile test, okay, now you have gone through stress and strain curve. You have gone through stress strain curve in your strength of material, in your machine design, in your theory of machine. Very important curve. Okay, stress strain curve. Okay, so tell me the first thing. After conduction of this tensile test, are you getting stress strain curve? Through this tensile test, are you getting stress strain curve? Is this stress strain curve output of this particular tensile test? Is it output of tensile test? Stress strain curve, which will show the behavior of this particular material. Are you going to get the stress strain curve directly from the tensile test? Now answer me. Is it the output of tensile test? Because in SOM also you have studied that stress strain curve, stress versus strain curve. Okay, is it the output of tensile test? Answers. Tensile test. Okay, okay. Let's see. Let's revise some of the things. Okay, so some you have studied already. See, first basic concept here is stress. First basic concept here is stress. Okay, you can unmute or you can chat. What is the definition of stress? What is the definition of stress? What is mean by stress? A simple stress. Okay, I am not asking about the shear stress or bending stress. A simple stress. Okay, okay. So all are agree with the force per unit area. Okay, if you are saying stress is the force per unit area, Can you tell me what is the pressure? What is the pressure? You are saying that stress is force per unit area. Now my question is, what is the pressure? Acha, internal resistance per unit area. Is it a pressure or force? Sorry, pressure or stress? One of your colleague has answered that. Acha, stress. Okay, okay. So see, understand the basic difference. Okay. So see, such type of questions will be there, right? Such type of questions will be there at the time of your quality interviews. Getting it? While calculation purpose, you are using it force per unit area. Agreed. Okay. Applied force divided by the area over which that particular force is applied, that is stress. But the definition or the concept of stress is that it is internal resisting force. It is internal resisting force per unit area. Okay. So whatever the force you are considering for calculation, it is not the force that you have applied. Amount is same, number is same. If you have applied 10 kg or sorry 10 newton of force, then you are using it for the application, sorry, calculation purpose. Because when you are applying 10 kilonewton force to some material, similar kind of force, resisting force is given by the material. If you are applying 10 kilonewton, material is also resisting with the 10 kilonewton. So that 10 kilonewton is not applied by you. The 10 kilonewton is resisting force given by material. Okay. So that 10 kilonewton you are using, the force you are using is not you applied. Force you are using it, that is the resistance force, resistive force shown by the material. Okay. So first thing is that stress is internal resisting force per unit area. Okay, internal resisting force per unit area. Okay. Second thing, through the tensile test, you are not getting stress strain diagram. Okay, clear this picture in your mind. Okay, when you are appear for quality interviews, such type of questions will be there for like DRDO, ISRO, BRC, or PSU, or IITs. Okay. See, stress strain curve is not a direct output of tensile test. It is there. See, nowadays the digital machines are there that will directly show you or that will directly give you printout of the stress strain curve when you will go for the tensile testing. Okay. But that is after the calibration. See, you are not applying the stress. You are not getting the strain. What is there? You are applying force and you are getting deflection. Are you getting? You are applying force and you are getting the deflection. Change in dimension. Okay. So initially output will be force versus deflection curve. Force versus deflection curve, which is then converted into stress versus strain. By dividing by area to the force, you will get a stress. By dividing with the original dimension, you will get a strain. Getting it? Okay. So output of the tensile test is force deflection curve and not the stress strain curve. Okay. Ultimately, it is a stress strain curve only. That is the machine output. Okay. But the test output is a force versus deflection curve. Okay. So through that, you will get to know the tensile strength of the material. Okay. Stress, you have answered properly. Now tell me, what is mean by strain? Answer it fast, because we do not want to invest so much time on this. This is not a part of our syllabus. I'm just recalling your concepts. Okay, tell me fast, what is mean by strain? What is mean by strain? What is the meaning of strain? You told me about the stress. Now, what is the strain? A very simple concept that you have studied in your SOM, ratio of change in dimension upon original dimension. Okay. Okay, so that's great. Okay, ratio of change in dimension. don't define it as change in length on original length. Okay, don't define it that way, right? So okay, now right, change in dimension on original dimension. Okay, firstly we will cover this, right? So there are two types of strain, longitudinal strain and what? One is longitudinal strain, another is a, what is another? Right, you will have to brush up your concept, lateral strain. Okay, now define fast. Longitudinal strain, longitudinal strain, longitudinal strain along the axis, along the axis. Okay, and lateral, okay, lateral strain, perpendicular. Okay, that's great. Okay, so good. Actually, the our final year students are also replying it in wrong way. Okay, so longitudinal, it will be the change in dimension along the direction of application of load, and lateral will be perpendicular to the direction of application of load. Okay, don't define it in a way like longitudinal strain equal to delta L by L. Okay, dl by L. Okay, change in length by original length. That is not longitudinal strain. Okay, if you are applying it in a lengthwise direction, no problem. Okay, but longitudinal strain dl by L, lateral strain delta d by D, that way you need not to define. Okay, depending on the direction of application of load. Okay, so that is also good, you are clear with that. But but there is one more thing, engineering strain and two strain, right? Engineering strain and two strain. In this tensile test we are considering engineering strain and not the true strain. Okay, this question is asked for your gate or in your IS also. Engineering strain means what? When you are comparing the dimensions with respect to original dimensions and final change in length. Means suppose if I want to calculate longitudinal strain, and if I will take delta L by L, the L stands for original length and delta L stands for change in length. And how we are calculating change in length? Original length minus final length, or final length minus original length, that difference. Okay, that is called as the engineering strain. And two strain is that strain when you are considering instantaneous change in length. Are you getting? In case of engineering strain, you are considering a final change in the length and not the instantaneous. Are you getting? Final change means at the start, if suppose length of the bar is 10 meter and after elongation it has become 15 meter, the change in length is 5 meter. Okay, but that is at the end, not the instantaneous. Okay, so it is the engineering strain which is not used in industry, which is not used for practical applications. Okay, practical applications, true strain is used. True strain is instantaneous change in length. Means at particular point of application of load, what is change in dimension? Suppose for 10 kg, what is change in dimension? For 15 kg, what is change in dimension? Okay, that way. Okay, so there is difference between engineering strain and true strain. Okay, and there are some more concepts also, that area under stress strain diagram. It is called as modulus of toughness. Okay, right. So again, you can understand the nature of material also through the tensile testing. Okay, if it is a ductile material, the fracture will be like cup and cone type. Now, if you are having mild steel bar, or plastic is also a ductile material. Again, depends on the composition. If suppose you are having ductile material, and if there is a fracture of ductile material in a tensile testing, you will find the fracture is of cup and cone type. This is the last year IS question, and 2 3 years back it is also asked in a gate also. So cup and cone type material, sorry, cup and cone type fracture in case of ductile material, and crossed plane type fracture in a brittle material. Okay, we'll not go in a more depth. Okay, so ultimate aim of tensile strength is to understand tensile strength of the tensile strength of the plastic. Okay, or ultimate stress, elongation, how much it can bear the tensile loading. Okay, that is a tensile test of this particular plastic, right? Mostly not preferred because it is used for the metallic materials, right? Okay, so still we are having two three more tests, like flexural test, impact test, and tensile impact energy test. Okay, so that we'll see in the next lecture. I think in afternoon only we are having one more lecture. That time we will continue this. So for today, what we have seen, see the applications: polyester, PET, polyethylene, HDPE, PVC pipes, PVDC for food packaging, polyamides, ABS plastic for electronic components, toys, polycarbonates like disc, suitcase, even some components of the electronics applications. Then the combination of PC and ABS, mostly for interior design of the vehicles. Polyurethane, that is a foam. Then melamine formaldehyde as an to cover the surface only. Okay, as a surface covering. And this is last as a epoxy, mostly used for the manufacturing of composites. And then this testing method. Out of that, we have seen the tensile test, right? So, in afternoon session, we'll see about the flexural test, impact test, and this tensile impact energy testing. Okay, so this testing part we will cover today, so that we can move ahead with the next part. What is next? Right. So testing method, and next is additives in the plastic. Okay, so that part we will cover today. Okay, so Vinayak. Right, so we'll stop here. Just a minute.